Okay, so day 2, the rational root theorem. So just to recall, yesterday we looked at 2 different type of factoring techniques. Factoring in a quadratic form, where that's a trinomial, where the degree is 2 times what the exponent of the middle term is. And then we looked at factor by grouping as well. So you need to be very, very good at factoring and making it automatic. Okay, so rational root theorem. Here we have our polynomial, degree n, integral coefficients, and a non-zero constant term. So in order to solve this polynomial on your quiz, on the first few lessons, we gave you a root. So you have a root of a, you know that's a root, then we use synthetic division, we set it up, we verified a remainder of 0, and then we were either able to continue synthetic or take our quotient and factor it to solve. So now that information isn't given to you. You have to determine that information. So x equals p over q, where p is a factor of the constant term and q is a factor of the lead coefficient. So now the possible rational roots come from this ratio. Okay, so p are all the roots of your constant, and q are all the, not the roots, the factors of your lead coefficient. So let's look at an example. List all possible roots. Okay, so p are the factors of your constant term. So the factors of 2 are plus or minus 1, plus or minus 2. Q are the factors of your lead coefficient. So the factors of 3 are plus or minus 1, plus or minus 3. So then your possible roots are the ratio of each of these possible combinations. So x can be plus or minus 1 over plus or minus 1, plus or minus 1 over plus or minus 3, plus or minus 2 over plus or minus 1, plus or minus 2 over plus or minus 3. So check out where these numbers came from. So all the numbers in the denominator, these are the factors of my lead coefficient. The numbers in my numerator are the factors of my constant term, that p term. But you have to understand that I'm making a fraction. I'm listing p over q for all the possibilities. So that's why I took the, notice here, I took 1 from my factor of my constant term and I put it over each factor of my lead coefficient. Then I took 2, which was the second factor of my constant term, and I put it over each factor of the lead coefficient. So these are the possible roots. And this is what we're going to work on today, or in the video. We'll talk about how this actually will help us factor a higher order polynomial. Okay, so list all the possible roots. P. Okay, so p are the factors of my constant term. And notice I use plus or minus. It doesn't really matter that this is a negative 4. The factors of 4 are 1, 2, and 4. Okay, 1 times 4 is 4, 2 times 2 is 4. So we would only have to list the 2 one time. Q are the factors of my lead coefficient. So 2 is a prime number, so the only factors of 2 are 1 and 2. Okay, so then the possible factors are all the ratios of P divided by Q. So I'm going to take 1 from my factor of my constant term, and I'm going to divide that by each factor of my lead coefficient. So 1 over 1, 1 over 2. All right, let me fix this up a little bit. Okay, so I've done all the ratios with 1 as my numerator. So now I'm going to move on to 2. So I have plus or minus 2 divided by plus or minus 1. And then I get plus or minus 2 divided by plus or minus 2. So now I've taken the factor of 2 from my constant term and I've divided it by each factor of the lead coefficient. Okay, then I have plus or minus 4 divided by plus or minus 1, plus or minus 4 divided by plus or minus 2. So I took my last factor of my constant term, which was a 4, and divided it by each factor of my lead coefficient. Now let's check some things out here. These are all the possible roots, but look at what repeats. So this would just be 1, 1/2, 2. Now 2 divided by 2 is going to give me 1 again, so we don't have to check that again. 4 divided by 2 just reduces to 2, so I don't have to check that again. So the numbers that I would check into my function would be plus or minus 1, plus or minus 1/2, plus or minus 2, and plus or minus 4. Okay, again, these plus or minuses just means that you have to check both the positive and negative roots, and we'll work on what that looks like. Okay, so here's my lead coefficient is 6. So factors of Q. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All right, and then my constant term is 5. So the only factors of 5 are plus or minus 1 and plus or minus 5. Okay, so all my possible roots are the ratios of P divided by Q. So now when I make these, my 1 from my constant term, I have to divide it by 1, 2, 3, and 6. Plus or minus 1 divided by 1, plus or minus 1 divided by 2, plus or minus 1 divided by 3, plus or minus 1 divided by 6. So I took my factor of 1 from my constant term and I divided it by each factor of my lead coefficient. So that gave me 4 possible factors I can check. Okay, now let me move on to my factor of 5. So I plus or minus 5 over 1, 5 over 2, 5 over 3, and 5 over 6. So I took 5, the second factor of my constant term, and I divided it by each factor of my lead coefficient. So the possible roots would be plus or minus 1, plus or minus 1/2, plus or minus 1/3. So notice I'm just getting rid of the double plus or minus. I'm just writing it as what rational numbers I'm going to plug into my function. Plus or minus 1/6, plus or minus 5, plus or minus 5/2, plus or minus 5/3, plus or minus 5/6. So nothing repeats here, okay? So this is a lot of possible rational roots. Okay, so for your homework, I would just like you to move on to example 4 and do this. Determine all the possible roots. So list the factors of 4. Divide that by the factors of 2. And then simplify the fractions so that your answers will look in this form, okay? So try this one thing for homework tonight.